started. Just started, Michelle.
Just take one.
It's even better.
Malonic and spirit coffee.
Okay.
What was in before you poured it in?
Just water.
Just water.
And there's potassium bromide and the potassium carbonate.
Gets the yellow cloud.
Nice.
That's the bromine.
Mm-hmm.
Here's the balance.
Ooh, nice.
Don't you want to? Oh yeah. Oh, this
Nice.
This one is this cloud.
Look at that. That is nice.
Usually we wait for the cloud. Oh, that's all right. Okay.
Put,
Yeah, there. Yeah, this. Oh, this is beautiful.
Mm-hmm.
Okay.
how long did you do this for?
An hour?
Back and forth.
An hour.
It can do it
Well, we've got about
Oh,
16 minutes. We've got 16 minutes more of reaction time on
Oh,
the.
look, it's changing colors now. That's nice.
Mhm.
Well, I
It
thought
starts
it
to
was.
slow down now.
Does it look all right?
It looks very good. You want to take a look at it?
So the background is okay?
It looks fine.
I think so.
Yeah, it's
Yeah.
fine.
Yeah. Okay. Is it turning? Huh.
It's changed colors. I mean, it went from yellow to that.
The sequence of throwing these things in was not the way we always do it. Usually,
Oh, there it goes.
Ooh,
Yeah.
nice.
that's good.
Yeah, it was
Yeah.
quick from
Usually
blue
what
to
you do,
brown.
You put the stuff in, you get the bromine
Yeah,
formation,
and
then you get cloudiness.
Wow.
Then you wait until the cloudiness goes away,
I
and
knew
then
there
you
was
add the
something
metal.
I was forgetting.
Okay? So,
Well, good job. You taught us something new today.
huh?
I said she taught us something new today. She told us that we can, I mean, it worked out just fine.
It worked, but, what we want to do is we want to sort of get the same sequence in the
Right.
future all the time.
Right.
And so now it's not really coming back to really red, right?
Yeah, not really.
But
Ooh.
it's becoming very nice blue.
Wow.
It's not really going back to the same
That's
bright
supposed to be
red.
the red?
Yeah, it's never going back to the same kind of
Like
red,
brown.
but the blue is actually clean.
Mm-hmm.
Yeah,
Sometimes
supposed
it's
to
the
be a
red
little
that is more clean, sometimes it's the blue, and
The blue is very clean.
yes. And what we need to do is, once we have this as a movie, we'll get it on the computer, and then Mary and Carmen, they can determine the time and the height of the blue spike.
Can I have a copy
There.
of this?
Yes?
Yeah, definitely.
My students would like to see this, I bet.
Yes.
Yeah.
This is like an easy reaction too. Like you could just.
So, I mean,
I really don't want to bring the chemicals in, though.
Oh, I gotcha.
It's nicer like that, right? Once you have it recorded.
Yeah, because I'm just too lazy to physically bring the chemicals in.
where do you teach at again?
I'm a student teacher at Gentry Middle School.
Oh, cool.
Pretty cool.
They would find it really
Fascinating.
exciting.
Yeah.
Because I was making molecules for them on the computer
Really?
the other day, and they thought that was the coolest thing ever.
You did?
Yeah.
I
They
think I'm
were-
doing my homework as we
So you're using your research abilities?
Yeah. I
Oh,
mean,
good,
like,
good.
yeah. And I was doing simple ones. I would do, like, water, and they thought that was, like, the coolest thing.
You made what now?
water.
Just a water
Water.
molecule, and they thought that was
Wait,
so
what?
amazing.
CamDraw or?
I found one online, but I could do, like, space still, so.
That was pretty cool.
There's great opportunities to bring research
Yeah.
on the chemistry lab
Yeah.
in the school like that with online stuff.
Mhm.
A lot of your older colleagues there, they were not exposed to modeling when they were students.
Mhm.
That is true, yeah. Modeling's
Yeah.
pretty new stuff.
And many of them don't have a master's. So they
Most of them just have a
they really
bachelor's.
don't know anything about research, I mean, she has been tortured for 2 years.
Mm-hmm.
Over
Just three more years, nothing more.
Yeah.
Yeah.
2.5.
Yeah.
You're gonna be done in 5.5. That's
When
pretty
I
No, I
good.
was
was getting
tortured,
master's.
I expected
Oh,
to
just
say that.
master's?
Oh, no, you didn't.
You're not gonna get your PhD. No.
So this is nice. The blue
Yeah.
comes out real nice and clean.
Yeah,
And we've
it's a
got
little
at least
brown.
12 more
I
minutes of.
want, but
Yeah.
Blue is very nice.
Mm-hmm.
Yeah. See, that has to do with the fact on how much metal you use.
Mm-hmm.
Because what you basically have is you put in iron 3, right?
Right.
Iron 2. You put in iron 2. And then there's a certain reservoir. And then the amount that gets, well, no, hold on. How does it get? It gets oxidized to iron 3, and then the back reaction of iron 3 to iron 2, that depends on the concentration of the bromomalonic acid.
Right. That makes perfect sense.
Yeah. So if you have a lot of bromomalonic acid, then the back reaction should always be taken care of. Well, I'll have to think about this a little more. But no, which one is which? The blue one is which?
Iron 3.
The blue one is iron 3.
And the red one is what, iron 2 or something like that? Yeah, that's what I think.
The red one is iron 2. And we're not getting the red clean.
Not really.
No.
So that means there's always some iron 3. Okay.
Is that,
Yeah. Well, that makes sense.
Does that mean we put in too
That
much
makes
iron?
sense because what we do right now with this, with all these studies is the organic reaction is with the bromomalonic acid or the hydroxymalonic acid or something like that with the iron 3.
Right.
Right? So, and if so at one point we have only iron 3, but then yes, when it's blue we have only iron 3, right?
Right.
And then we're converting not all of it back to iron 2. That's why it's never really clean red. There's some iron 3 left.
so does that mean there's too much iron? 3?
Yeah,
Okay.
yeah. I think we put a little too much iron in it at the beginning.
Okay.
So if you would put a little bit less iron in it at the beginning,
Less than 2 milliliters?
yes, then you should be getting
Red.
a cleaner red and a less clean blue eventually if you overdo it.
I feel like that's happened before, hasn't it? I
It
feel like
happened
I've
before.
seen
It's never
the
really.
cleaner red
Yeah, we
and
never
then
get it
the dirtier
exactly
blue.
right.
Yeah.
Yeah.
We can always try it again later.
Yeah. But I mean, we're getting the blue really clean, right? So it's either one or the other is probably very clean.
Right.
Yeah. So this is nice.
Yeah.
And this has been running, what, 10 minutes?
Yes, sir.
Something like that?
Almost 10 minutes.
Okay, and do you have enough?
We've got about 8 more minutes of video recording time.
Yeah, let's go for the whole thing.
Okay.
And,
I mean, can it potentially go on infinitely?
No, usually you'll see like it just won't go as clear or as long, and it'll just start.
After like an hour, doesn't it just kind of stay red?
I think so.
And from all the simulations, you know that the amplitude declines.
Yeah.
Right, so it's just not as.
So the
not
blue
as
is getting
high.
less intense over time, and the red gets less intense over time.
It's kind of like like this and then it goes down. Dies off.
Yeah, it's nice. It's beautiful. Yeah, and we'll have no trouble at all to determine the sign. The blue comes in real sharp.
Right. It's just when the
And I'm
red
sure you
comes
can
in.
analyze the video some more too.
Yeah. Yeah, that's why I don't think we need to watch actually, because the video has the time on every frame.
Yeah.
There are lots of fancy things we can do with video editing software.
So, do you know how to get that off? and put it on a computer?
Oh yeah, definitely.
Right. And do you know what format it is? Is it an
I
AVI?
mean, it's probably going to be in the form of a movie. What's that, MVI?
AVI.
Well, I mean, AVI, yeah. It depends on whether I use Windows Media Player or if I use another
Your
software. I mean, I've got I guess an Olympus software that came with it that edits videos too, or I can use Windows Media Player. Whatever you want me to use, or I can use both of them and you can see which one's best. And
So, I think this is success, right? We now know how to do this, we know how to do the recording. So what you need to do now is you need to come up with a plan for next week when you want to set aside quite a bit of time to do this reaction multiple times with different concentrations of acid.
Different concentrations.
Of acid. And what you want to do is you want to prepare a little bit of, you want to go in your Excel sheet, you know, and think, what do you have to do everything exactly the same? So you have to have the same volume so that none of the other concentrations change, but you want to set it up such that you have different amounts of acid. Yeah? And we want to go from the standard we have now, you know, that pH level, right? We want to go and start at 1/10 of that acidity and go all the way to 10-fold acidity.
Okay, 0.1 to 10 times?
Yes, 0.1 to 10 times. And, you know, we can go in steps of whatever you want to do.
0.1, we can do 0.1. I mean, I guess it depends on how much time you have, because I have a lot of time on my hands, you know, so...
Well, the easy one would be, you know, you start with 10 times as much and then you dilute it to half that or something, you know, you just...
I can probably come in this weekend and do a lot of, like, the calculations and how much concentration we're going to need. And that way, you know, when we just come in next week, we have all our data ready. We could just start making the reagents or whatnot. If you want me to do that.
Yeah, I want you to take your time. I really want you to think this through. I don't want to have anything like, you know, we'll have to be worried later that they do it right or something, right? So you guys think this through, make damn sure it's right, you know, then do it.
Okay.
And it doesn't have to be equi-spaced.
Okay.
You know, it doesn't have to be like 10 times, 8 times,
oh, okay.
6 times or whatever, right? But I like to